Okay, so today we're going to be combining the concepts that we had of solving one-step equations and all the work that we've been doing with fractions through modules 1 through 3. So let's jump in here and look at this first problem on your note guide. We have n plus 2/3 equals 1/3. And just like before, we say, okay, what are we trying to solve for? And we are looking and we see here's our variable. That's what we're trying to isolate. I have an equation, so I always draw a dotted line through the middle just so I remind myself whatever I do to one side, I got to do to the other. And we're going to start off treating this just like an integer, okay? So if this was plus 2, what would you tell me to do? Hopefully you'd tell me, well, the opposite of addition is subtraction. So we're going to subtract whatever this number is from both sides. In this case, it's the fraction 2/3. So we're going to subtract 2/3 from both sides. Now, this is where our fraction work is going to come into play. Just like before, since we use the opposite operations, these cancel. We get left with the n on the left side. The easy part's done. Now what we need to focus on is this guy over here. What is 1/3 minus 2/3? And what we should remember here is that the denominators are the same, so there's no extra work we have to do. The denominator stays the top, and all we do is work straight across, or to the bottom. There's nothing we have to do, and we just have to work straight across the top here. So here we're just on the top, we're just doing 1 minus 2, which is a -1. Now with fractions, we normally don't put the negative sign on the top. We normally put it out on the side of the fraction. So this is -1/3. So again, problem with a fraction looks a little difficult because there's fractions involved, but we know the steps. We know what we need to do. We just got to remember, how do we deal with those fractions? Okay, let's look at that second problem that's on your note guide. And the second problem is we have h minus 1/3. So we have h minus 1/3 equals 3/4. Now, what I want you to think, we're going to isolate this variable. We're going to draw our dotted line through the equal sign because whatever we do to one side of the equation, we're going to do to the other. So what should I do to both sides of this equation? Well, I see that they're subtracting 1/3. So I'm going to go ahead and add 1/3 to each side. And here's going to be the first fraction problem where we see we got a little bit more work to do than a normal solving problem. Again, these guys are going to cancel off, make 0. So it'll just be h plus 0, which is h equals, and now I have to worry about, I have 3/4 plus 1/3. And you should be thinking, I am not allowed to add these together yet because I do not have a common denominator. So if you're looking at this, I have a denominator of 4 on the first fraction and 3 on the second. What would be the least common denominator I can get to make these fractions? We should have came to the conclusion that 12 is the least common denominator for both these fractions. They're the least common multiples for 4 and 3. So if we look up here, to turn the 4 into a 12, I need to multiply this by 3. Whatever I do to the bottom of the fraction, I'm also going to do to the top. So 4 times 3 is 12. 3 times 3 is 9. Plus, when I look at the other side, 3 needs to turn into a 12. So this would be 3 times 4. Throw the 4 on top here as well. And I end up with 1 times 4 on the top is 4. And now I have a fraction that I'm allowed to add together. The denominators are the same, so I get 12. And the top is 13. And we got one more step we got to do. 13/12 is an improper fraction. The top is larger than the bottom. How do we convert this over? Well, how many times does 12 go into 13? Goes in once. If I take that 13 and subtract off the 112 that I just said went into that, I get left with a 1 on top and a 12 on bottom. So this is h equals 1 over 12. So again, fractions, as long as we know the basic rules and we're able to execute them, we wound up with having two fractions that needed added together that had uncommon denominators. So we had to get a least common multiple or the least common denominator, convert those fractions over into equivalent fractions, and then once we had the improper fraction, break it down to be the proper fraction or the mixed number 1 and 1 over 12. Let's continue on your note guide. So the next one, we got 1 over 6 times x, 1 over 6 times x equals 2 over 5. And what we should be thinking here, again, we're going to undo any multiplication or division being done on this variable by using the opposite operation. And whatever I do to one side, I'm going to do to the other. So what we should be thinking here is that I am multiplying x by the fraction 1 over 6. Now, normally we would say, oh, we're going to divide by 1 over 6. But this brings up an issue. What do you do when you are dividing by a fraction? And there was a two-step process. You change it to multiplication, and we take its reciprocal. What's the reciprocal of 1 over 6? We should have came up with the answer 6 over 1. And we'll multiply 6 over 1 to both sides here. Why do we do this? Well, if we look, I have a 6 on top and bottom, a 1 on top and bottom. These fractions are going to cancel off and make just 1, which leaves me with 1x, just like we did whenever we were solving those other ones. With the integers, we were just trying, or the decimals, we were trying to get just the x left, and that's what happened here. Now, for the multiplication of fractions, we should remember we just multiply straight across. So 2 times 6 is 12. 5 times 1 is 5. And again, I'm left with that improper fraction. What would be 12 over 5 if I was going to convert it to a mixed number? You should be thinking 5 goes into 12 twice, which is 10. So if I take those two 5s out of the top of the fraction, 12 minus 10 is 2. So this winds up being 2 and 2/5. So in this problem, x is going to equal 2 and 2/5. All right. We got one more to go over, and then you guys will be done listening to me for the day. We got the problem, and this one looks a little weird, but it's no different than what we just completed. We have 3 over 4t, or 3t over 4, equals negative 2/5. Now, whenever you look at this, we can see our t is up on the top of the fraction. That's not going to change anything that we do here, okay? I'm not going to touch that t. I'm going to focus on the 3 over 4 instead. And what would I do to cancel multiplying t by 3 over 4? Well, we can't divide by a fraction. Instead, we multiply by its reciprocal, which would be 4 over 3. So I'm going to multiply both sides of this fraction by 4 over 3. And some of you might be asking, Mr. Scheer, why'd you just put parentheses over top of that negative 2/5? Because of that negative sign. I don't want to forget there's a negative sign there, so I wanted to protect that real quick. So here, the 4's cancel, the 3's cancel, we get t equals negative 2. Well, let's just do 2 times 4 is 8. 5 times 3 is 15. And we had a negative times a positive, which leaves us with a negative answer. So there we go. Go ahead and move on with your lesson. See how you guys did. If you